I want to take a quick look at some properties of double integrals. I don't think you'll be surprised by these properties, but anyway, the properties are true nonetheless. Here we go. Here's my first property, the double integral over a region D of a sum of two functions. Is the sum of the integrals. This is provided, of course, that all the integrals exist. So the integral of a sum is the sum of the integrals. Not surprising. That's the way it worked for single integrals, right? Definite integrals that we did back in Calc 2. Second, if you take the double integral of a constant times a function, that's the same thing as the constant times the integral of the function. These two properties together, those of you who've taken some linear algebra may be used to these things, that you've got something that essentially distributes over addition and commutes with scalar multiplication. You're talking about a linear operator, right? An operator, for those of you who haven't heard the term before, an operator is essentially a function on functions. Think about what a function does. It takes numbers in, spits numbers out. Well, an operator takes functions in and spits functions out. Classic example is the derivative. You plug sine x in, you get cosine x out. You plug x squared in, you get 2x out, right? That the derivative is an operator. It happens to be a linear operator as well, because the derivative of a sum is the sum of the derivatives, and the derivative of a constant times a function is the constant times the derivative. Anyway, so there's a whole bunch of different operators that behave like this, that they essentially distribute over addition and commute with scalar multiplication. They're called linear operators. Anyway, if you're interested in linear things, try taking a linear algebra class. It's a lot of fun stuff. 3, there's the dominance theorem here that says if f of xy is greater than or equal to g of xy for all xy in the domain D, then if you integrate over the domain D of the integral of f, and you integrate g over the same region, well, if f is the bigger function, it's going to give you the bigger integral. Okay. And one last what do we call these things? Properties. There we go. A double integral over region D of a function of two variables is equal to, and here I'm going to draw a picture. I've got my region D here, and I want to split D into two pieces. So there's D1 and D2, okay? And that I can integrate over the whole thing, or I can integrate over each part and add the results together. Now, this is only true if, well, first of all, D1 union D2 equals the whole thing. And if I look at the intersection, D1 intersect D2, then the area of this equals 0. That is, they got to intersect on just a small piece. There can't be a big overlap. So yeah, they do overlap along that edge, but only that edge, and that's okay. We had a similar thing with with single integrals, right? We said that the integral from a to b of f of x dx was equal to the integral from a to c of f of x dx plus the integral from c to d. No, what the heck? C to a, c to b. There we go. I'm here. F of x dx. Right? You said integrating all the way from a to b was the same thing as integrating from A to C and then stopping and then starting again from C to B, and you get the whole thing one way or another. I don't know if your Calc 2 teacher pointed out to you that there is a little bit of overlap, that C gets counted in both of these integrals, but it doesn't really matter because that integral from C to C, some people say from C to shining C, but anyway, that integral is just 0. Likewise, here, that this intersection gets integrated over twice, but as long as the area of that intersection is 0, then it doesn't actually contribute anything more to the value here. Okay. So there's your basic properties of double integrals. It's quite often the case that you're trying to do something and it's too tricky to do, but it's easier if you split the domain up, and you might be able to integrate one way on this part of the domain and integrate another, some other way on the other part of the domain, because we're going to be able to switch our order of integration and things. But yeah, I mean, these are things that are going to allow you to manipulate the double integrals and hopefully make them easier to evaluate. So there you go, basic properties.